Hey guys, so I'm here making the first video on student common ideas. My video is going to be on acceleration. I'm going to show you some common ideas that students have, give you some examples of how you can relay the information to the students, then hopefully have a better idea on how the students perceive stuff. Okay, so we're going to go ahead. And some common acceleration ideas. Some students have the idea that the same velocity means the same acceleration for two different objects. They also sometimes believe that larger velocity means larger acceleration. For example, when you're driving in a car, stomp on the gas pedal, students believe that that means you're accelerating, but if you're slowing down, they believe that you're not accelerating. Also, if an object is accelerating, then that automatically means that it's moving faster, which ties back to the idea in a car where a lot of students believe that you're only accelerating if you're standing up versus if you're speeding up versus slowing down. Okay, so the first idea that we're going to deal with is the same velocity means same acceleration for two different objects. The students find it difficult to differentiate position, velocity, and acceleration, which Dr. Cheney covered in her video previously. This leads them to assume that two objects with the same velocities will also have the same accelerations. So, if we're going to give an example, so let's say that two cars are racing. Racer 1, we'll call Kevin, starts at t time equals 0 seconds, and racer 2, we'll call Wesley, starts at t equals 1 second. At time t equals 4 seconds, the cars both have the same speed. Who has the higher acceleration at t equals 4 seconds? So a lot of students might believe that because both of the cars are at the same position at the same time, then they have to have the same acceleration. But since both of the drivers, Kevin and Wesley, reached the same speed at t equals 4 seconds, it took Kevin more time to get to that speed than it took Wesley. This therefore implies that Wesley had a higher acceleration because he went to the same speed in a shorter amount of time. Which brings back the main idea of acceleration, which is that it's the change in the velocity divided by the change in the time. So Kevin starts from t equals 0 seconds and goes to 4 seconds. That's a total of 5 seconds. Wesley starts at t equals 1 second and goes to 4 seconds. It's a total of 4 seconds that he's traveling. So he gets to the same speed in a shorter amount of time, which implies that Wesley has a higher acceleration. So the second idea is that larger velocity means a larger acceleration. Now, this has a lot to do with the fact that some students have trouble differentiating between position, velocity, and acceleration. Students might tend to treat velocity as an indicator of acceleration, but fail to realize it is the ratio of the change in velocity over the change in time. So here's another example. Let's say that Idris is riding his bike and the speedometer on his bike reads 15 miles per hour. At the same time, Chris looks at his bike and he sees that his speedometer says 30 miles per hour. Who has the larger acceleration? So to you, you might be saying, well, you can't determine that, and you're absolutely right. The answer is that you cannot determine who has a larger acceleration. The acceleration is not contingent on just looking at their speed at one instant, but rather looking at the change in their speed over a certain time frame. So we're going to go ahead and go to the last student idea, which is that if an object is accelerating, it is moving faster. A lot of this stems from people riding in cars. They believe that accelerating, like I said before, means speeding up. So the idea that acceleration only means that an object is increasing its velocity is common. It is used whenever somebody rides in a car. If you're accelerating in a car, you're told that the car is speeding up. However, if a car is slowing down, that does not mean that it is not accelerating. So, if Christina is in a car and she goes from 0 to 60 miles per hour in 10 seconds, and Daniel goes from 60 miles per hour to 0 in 10 seconds, who out of the two have the higher acceleration? And the answer is that the acceleration of the two cars will be the same, but with different signs. This will show the students that acceleration does not just mean speeding up, but it is the change in velocity over a certain time frame. So the acceleration will be the same, but just in a different direction. So the acceleration for one will be negative and one will be positive, depending on your reference frame. Alright, so there's a couple of student common ideas, and I hope you guys enjoyed it.